Hello my dear students, welcome you back to video lecture of operating system. Already we have started unit number 6 and it is a last video lecture of unit number 6. So in this video lecture we are going to discuss 6.3 directory structure, logical structure of storage, different RAD levels. After watching this video, student can easily explain directory structure in the operating system. Second, student can explain disk organization and disk structure in operating system. And last, student can easily explain RAD structure of disk, RAD level 0 to 6. My dear students, in 6.3, first point or first question is what is a directory? How the directory structure is available in the operating system, or what are the different directory structures available in the operating system. So directory is a container of file. So it is very simple. A directory is a container of a file. A file is a unit of data which is stored in the secondary device or secondary memory. So directory is a collection of files. It may be of same type or it may be of different types. So it is a diagram of that directory. So directory containing the single file or multiple files of same type or different type. The next important question is how the disk structure look like. Okay, basically this question arises when you are storing the data on the secondary storage. So generally we have seen this in hardware maintenance, how the hard disk works, how the data is stored on the hard disk. So it is a relevantly available, or relevantly we have discussed this in the hardware part of your hard disk working. Okay, so disk is a secondary storage and it is a further divided into the sub drives using the partition. So disk is partition, or it is a divided logically into the parts, is called as a partitioning. Also it has a RAD protected. Generally the file system is mounted on a hard disk. Using the file system, we can easily access a specific file or specific data from the disk. Generally, file system works as index table to access the data. So this is a diagram which describes overall file system organization. So if this is your hard disk, it is subdivided into the partitions, and partition may contain directory and files. So it is a disk 1, and in disk 2 it may have a single partition. Okay, or single partition may contain some data from the disk 2 or disk 3. Okay, so it might be a combination of two physical disks. Okay, so directory organization, basically a directory is a container of a file. It is a logical container of your different or same type of file. Basically a purpose of directory is to efficiently access the logical file quickly. Second, naming means using the specific directory name we can segregate the data into the different parts. Okay, means we can create a directory. For example, we can create a directory like a SYCO, TYCO, then English, Maths. So relevant information or relevant files are stored in that directory. So naming conventions. So it is easy to find out the specific file from the storage. Okay, so naming, that is a convenient to user. So naming is one another use of directory, or naming is one another advantage of your directory. organization. And last, that is grouping. We have already discussed that grouping means we can combine together the same type of files and we can give the directory name as a Java program or game or music. Okay, so these are the basically 3 advantages of a directory organization. Efficiency in the accessing, naming means easy to find, and grouping means we can group the same files together and we can give the appropriate name so we can easily access that. So efficiency, naming and grouping are the advantage of directory. Then there are 3 types of directory structure: single level directory structure, then 2 level directory structure, and tree level directory structure. So what is a single level directory structure? In single level directory structure we have a directory and it contains a file. So it is a parent is a directory and it may contain a multiple files or it may contain a single file. So that is a single level. Okay, very simple. Single level म्हणजे काय, एका डिरेक्टरी मध्ये एकच फाईल असणं किंवा मल्टिपल फाईल असणं त्याला आपण सिंगल लेवल डिरेक्टरी स्ट्रक्चर म्हणतो. ओके, इन दिस टाइप वी हॅव प्रॉब्लेम ऑफ नेमिंग अँड ग्रुपिंग. ओके, बिकॉज every directory has its name, but in that we cannot directly access the file. So we can access the directory but we cannot have the specific file. Means if we have a directory and it may contain more than one file of different type, then it is not easy to find out that file. So naming and grouping are the 2 basic problems of single level directory. So it is not easy to name an individual file and it is not easy to group a same type of file in the single level directory structure. So these are the disadvantages of single level directory structure. In single level directory structure there is only one layer of directory and after that we have a files. Okay, so problem naming and grouping. This is avoided into a 2 level directory structure. In 2 level directory structure we have grandparent directory, that is a GP directory, then we have a directory and then we have a files. So a directory is contained in the parent directory. So it is a parent directory and then file. So these are the 2 levels of directory structure. So we have means a user is accessing user1 directory, in that there are subdirectory cat, bow, a and test, and in that directory cat we have a file. So it is called as 2 level directory. In single level there is only a single directory structure. In 2 level directory structure it has a 2 directories. So it is easy to find out the path. So we can identify an individual file or we can group the file. It is efficiently search. So this 2 level directory is used for efficient searching. Okay, path naming is very simple. We can have a same file name for the different user. Okay, so it is very important. In user, for that purpose we can go back and we have some discussion. Suppose आता बघा इथं डिरेक्टरी आहे, मी एक डिरेक्टरी तयार केली सॅम आणि सॅम मध्ये मी एक फाईल स्टोअर केली a.c. तर मला परत a.c ही फाईल ह्या सॅम डिरेक्टरीमध्ये क्रिएट करता येत नाही. इट इज अ बेसिक प्रॉब्लेम ऑफ युअर सिंगल लेवल डिरेक्टरी स्ट्रक्चर. नेमिंगचा प्रॉब्लेम येतो, याला म्हणायचं नेमिंग प्रॉब्लेम. ओके, नेमिंगचा प्रॉब्लेम कळला म्हणजे काय, एका डिरेक्टरीमध्ये एकाच नावाची एकच फाईल असू शकते. ओके, म्हणजे एकाच नावाची a.c किंवा a.text डिफरंट टाईप पण चालत नाही. ओके, इट मे हॅव अ डिफरंट टाईप बट इट हॅज अ सेम नेम. ओके, इट इज नॉट अलाउड इन द सिंगल लेवल डिरेक्टरी स्ट्रक्चर. जर मला सॅम ह्या फोल्डरमध्ये a.c नावाची परत एक फाईल क्रिएट करायची असेल तर इट इज अ नेमिंग व्हायलेशन होतं. ओके, कारण की हे डुप्लिकेट येईल, त्यामुळं a1.c नावानं ते सेव्ह होईल, पण आपल्याला a.c सेव्ह करायचं असेल तर इट इज पॉसिबल नाही. ओके, तर हे आपण अवॉइड कुठे करतोय, तर हे अवॉइड आपल्याला करता येईल टू लेवल डिरेक्टरी स्ट्रक्चरमध्ये, म्हणजे user1 ही डिरेक्टरी आहे, त्यामध्ये कॅटमध्ये मी a.c करू शकतो, बोमध्ये मी a.c करू शकतो, मध्ये a.c करू शकतो. सो इट इज पॉसिबल टू क्रिएट अ सेम टाइप ऑफ फाइल इन द different directory. So that is a naming problem is avoided. Okay, but there is a same problem, grouping problem is there. So a.c is scattered into the multiple directories, so there is no any grouping. So it is easy to find out the path, easy to find out the same, easy to create a same file in the same directory of different subdirectories. Okay, and there is a problem of grouping. So there is a problem of grouping. Grouping means what? We cannot gather a.c together. Okay, so that is a problem in two level directory structure, and all these problems are avoided in the tree structure. In tree structure we have a root directory, under that there is a parent directory, and then parent directory may have a child directory, directory may have a sub child directories, and then we have files. Okay, so root directory contain only a parent directory may contain a file. Okay, or parent directory may contain a child directory. So we can easily have efficient search. Naming problem is not there, because we can create a.c here, also a.c here, also a.c here. Okay, so naming problem is not there. Then it is easy to group together. Okay, so in tree structure it is easily we are grouping the together. So we can have a directory like this tyco, and in which we can have a list of students. So this is a very important directory structure, tree directory structure. Single level directory structure, there is no any parent directory, so directory and then file. Two level directory structure, parent directory, then child directory, and then files. So it is easy to naming in the two level directory, but grouping has a problem. In tree directory structure there are level of directories. So first it is start from the root directory, and then parent directory, child directory, sub child directory, and then file. Okay, so that is the structure. It will have efficient use of directory organization. So it is efficiently used for searching, path finding. So there is no naming problem, we can easily group the files. Okay, so this is a tree directory. It is efficiently search, it has a grouping capability, and it is easy for naming. Okay, so that is the advantages of tree structure. My dear students, up till now we have discussed what is a directory. It is a container of file. Then we have three type of directory structure: single level directory structure, two level directory structure, and third tree level directory structure. Basically directory structures are used, or advantages of directory structure is efficiency, naming, and grouping. In single level directory structure is the problem of naming and grouping. In two level directory structure it is a grouping problem. In tree level directory structure there is the efficiently search, grouping, and naming. Okay, so reflection spot. Up till now you have seen the directory structure. Okay, now stop this video, listen the question carefully. What is the different directory organization or directory structures used in the operating system? So what is the use of directory organization in the operating system? Write down your answer, take your time, play this video again. So basically directory structure organization is used, or benefits of directory structure is efficiency, to finding and retrieving, to locating the file quickly, naming, so easily identify that file, and grouping means we can group the same file together. So these are the three important advantages of directory organization: efficiency, locating, naming, identification, grouping same type of files together. Then next, it is a only revision part. Already this part is known to you, so it is a only revision part. In MSBT question paper from 6.3 there will be a definite question on directory and what are the different levels of directory. So it is for 4 marks. This is a primary knowledge of your storage. Okay, mass storage is a permanent storage on which files are stored permanently. So generally it is called as a hard disk. It may be a magnetic disk or it may be a magnetic tape. Okay, so basic hardware organization of your disk is like this. We have a spindle, okay, then we have platters on which the read-write head assembly is mounted. So it is a read-write head assembly. Every platter has read-write head on the top and bottom. So these platters are of a magnetic material and we are writing the information on these platters. So arms are moving forward and backward and your platters are rotating in the circular manner. Okay, so already you have known this organization, it is a revision. Then generally a disk structure, a logical disk structure look like this. So your disk is divided into the sectors, then cylinder and tracks. Track, sector and cylinder. These are the basically three unit of your disk, logical. A single part of the disk, okay, is called as a sector, or a circular area covered by the sectors are known as track, and cylinder. Cylinder is nothing but it is a collection of sectors of different tracks. So this is called as a cylinder. So these are the three units of your disk structure in the logical form. Okay, so it is a physically hard disk. So we have already discussed about the platter, read-write head, spindle motor, actuator and cylinder. So logical disk structure is a track. So its circular area on which a data is mounted is called as a track. A single or identifiable part in the track is known as a sector. Okay, and this is called as a cylinder. Okay, cylinder 0 means it is a container of all sectors, 0 sectors of all the tracks. Okay, अर्थ कळतो. सिलेंडर 1 चा अर्थ काय आहे? सिलेंडर 1 म्हणजे सिलेंडर 1 आपण केव्हा म्हणतो, हा जर आपण सिलेंडर 1 म्हणलो तर सिलेंडर 1 विल कंटेन ऑल द सेक्टर्स ऑफ सेक्टर नंबर 1 ऑफ ऑल द ट्रॅक्स. ह्या सगळ्या ट्रॅक मधला सेक्टर नंबर 1 जो होल्ड करेल त्याला आपण सिलेंडर 1 म्हणतो. ओके, सो दॅट इज अ लॉजिकल स्ट्रक्चर. जनरली लॉजिकल स्ट्रक्चर ऑफ हार्ड डिस्क is created using the partitions, or it is a logically partition. So we are dividing the hard disk into the logical parts is called as a partitioning, and inside we have track, sector and cylinder. Basically a logical structure of your disk contains 5 important things. So first is MBR, master boot record, then DBR, DOS boot record, then FAT, file allocation table, fourth root directory and data area. These are the 5 main components of logical structure of your disk. Master boot record will hold the information regarding from which location we are going to load the operating system. Okay, so it contains small program to load the partition information of the hard disk to your main memory. Okay, MBR is created when you format the disk. Okay, using the fdisk command. When you create or you format the disk, the MBR is created, and MBR is very important. MBR is generally located on sector 0, track 0, cylinder 0. Okay, on which it will be start the master boot record, which gives you information about from which location your operating system from the hard disk is loaded into the main memory. Okay, so it is like this: MBR, DBR and FAT root directory structure, logical structure. A DOS boot record, that is the second part. DOS boot record holds a partition table which having the information about the sectors, secondary information about the tracks and cylinder. Generally, DOS boot record holds byte per sector, sector per cluster and reserved sector. Basically, DOS records are used to hold the disk information, and where your track and sectors are started, this DOS, disk operating system boot record. Okay, so that is hold a sector information, cluster information and reserved sector information. Then FAT. FAT is file allocation table, which contain the index type of structure. Using the FAT allocation table, we can easily identify a specific data from the disk. Okay, it is a simple meaning, FAT. Then root directory. A root directory is like a table of contents which store the information about the hard disk drive. Okay, so generally it is having the information about the hard disk drive, about a file name, date and time when that file is created, attribute of file, file size, okay, and particular on which cluster that file is created. So general information of what file is stored into the root directory. And last, data area. The remaining value of a root directory is known as the data area. Data area contains actual data storage of the disk space on which data is stored. Okay, when you format the disk, the data will be lost. Okay, so my dear students, that discussion is only a revision of your knowledge. That is not asked in the MSB education paper, but in any case it is asked, then you must have a two type of structure of disk: physical structure, okay, where you can draw the diagram of spindle, platter and its assembly, and you can explain how the data is right on the hard disk. Logical structure, you must explain the logical structure of disk. You must have a track, sector and cylinder information, also proper diagram of logical structure. Also you can include 5 things in the logical structure, like master boot record, DOS record. Okay, so you have a FAT area, then data area and root directory. Basically these are the 5 main logical information stored in the hard disk. Okay, so that part is regarding the disk. Okay, physical disk structure and logical disk structure. Now it is a very important point in 6.3. what is a RAD and what are the RAD levels? My dear student, it is an introductory part to you. It is not in detail, but it can be asked for 6 marks for the notes. Okay, what is a RAD? Actually, RAD is nothing but redundant array of independent disks. This single word will elaborate the technique. In this technique, it contains multiple disks instead of a single disk for increase the performance and redundancy of your system. In general system, it has a single disk. If that disk fail, your system will fail. So RAD contains the multiple disks to avoid the problem of failure. So it increases the performance of your system. Also the redundancy. Redundancy is nothing but a duplication. Redundant, a duplication. A duplicate data is present, but it requires extra space. It increases the reliability, it increases the performance, it increases the मेंटेनन्स और इट इन्क्रीजेस द अवॉइडन्स ऑफ द फेल्युअर. ओके, ह्याचा अर्थ काय आहे की रिडंडंट डिस्क ऑफ इंडिपेंडंट डिस्क ॲरे म्हणजे काय, मल्टिपल डिस्क ह्या टेक्निकमध्ये कंबाईन केले जातात आणि तुमचा डेटा हा मल्टिपल डिस्कवर स्टोअर होतो. जर सिंगल डिस्कमध्ये स्टोअर झाला तर सिंगल पॉईंट ऑफ फेल्युअर आहे. ओके, तर त्यामुळे तुमच्या सिस्टीमचा परफॉर्मन्स डिक्रीज होईल. ओके, तर तुमचा सिस्टीमचा परफॉर्मन्स इन्क्रीज करायचा असेल तर तुमचा डेटा जो आहे तो मल्टिपल डिस्कवर स्कॅटर्ड करणं किंवा स्टोअर करणं, जी टेक्निक आहे त्याला आपण म्हणतो रॅड, redundant array of independent disk. So different advantages of RAD systems are, so this question can be asked, what is the RAD and what is the advantages of RAD. So RAD is redundant array of independent disk which increases the performance as well as reliability of system. So these are the 4 important advantages of RAD. First is reliability. Due to the multiple disk storage, if one disk fail, there will be no single point of failure, so it is a highly reliable. Then availability, due to the multiple copies of same data is available, so it can be parallelly used, so availability get increased. Performance, so there is no any problem of failure, so it will increase the overall performance of your system. And capacity, so if you have a number of disks and same data is mounted on the number of disks, then we can have a capacity to access multiple users, multiple systems at a time. So availability, reliability, performance and capability or capacity, these are the 4 advantages of RAD system. Then in our syllabus we have RAD level 0 to RAD level 6. In your MSBT question paper, there will be definite question, explain what is meant by RAD and what is a RAD level 0, 1, 2. So there will be definite question for the short note. In your short note, you must explain what is the RAD, what is the advantages of RAD. Okay, that question for 4 marks. If it is asked, explain any 4 RAD levels, then you must explain what is the RAD. Okay, and then what is the RAD level and RAD level advantages. Okay, so there is no any technical details. Okay, but you must have a primary knowledge about the RAD levels. In RAD level 0 is known as stripping. Okay, so what is meant by stripping? Stripping is nothing but we have a 2 disk. In the RAD level 0 we have a 2 disk and your data is stored on the disk 1 and disk 2. Suppose we have a data and it is divided into the blocks. So if you have a 10 blocks of the data, then block 1 is stored on the disk 1, block 2 is stored on the disk 2, 3, 4, 5, 6, 7 and 8. So every block is stored on the different disk. So if RAD 0 is there, there will be stripping. Stripping means dividing. So block 1 हा डिस्क 1 मध्ये असेल, ब्लॉक 2 हा डिस्क 2 मध्ये असेल. जर आपल्याला डेटा फेच करायचा असेल तर एका वेळी दोन्ही डिस्क आपल्याला रीड कराव्या लागतील. ओके, व्हॉट इज द ॲडव्हान्टेजेस ऑफ दिस टेक्निक? इट विल अवॉइड overall loss of data because your data is stored into the 2 disks. If one disk gets fail, a 50% of data is available. So you must recover only a 50% data. So that is the advantage. What is the drawback? So data is scattered into 2 different disks. It is not directly available, and if there is a loss, 50% loss of the data is there. Okay, so that is a problem, and it does not have a redundancy. Redundancy म्हणजे काय? इथं duplication of data नाही, इथं splitting, stripping आहे. Stripping of data is there. So अर्थ काय करतो? सिंपल एक्झाम्पल द्यायचं झालं तर तुमच्याकडे 1000 रुपये आहेत, तर तुमच्याकडे जर 2 पॉकेट असतील तर एकामध्ये 500 रुपये आणि दुसऱ्यामध्ये 500 रुपये ठेवणं. जर एक पाकिट जर चोरानं एखाद्या थीपनं जर कट केलं तर 500 रुपये लॉस होतील, पण 500 रुपये तर वाचतील, अशी कन्सेप्ट आहे याच्यात. ओके, अर्थ कळणं गरजेचं आहे. So you must have a technical knowledge about the RAD 0. So RAD 0 contain the 2 disks. in which data is stripping. So data is divided into two block and every block is stored on the different disk. So what is advantage? Not of overall failure of the system due to single disk fail. There is no any redundancy, but if there is a loss of single disk, 50% of data is damaged. So that is a RAD 0. In RAD 2, RAD 1, already we have discussed RAD 0. In RAD 1 is known as a mirroring. So mirroring is nothing but taking a copy of same data on the different disks. Okay, in RAD 1 we have two disks, and on the same disk, on the two disks, a same data is stored. Okay, data is divided into two blocks and same blocks are stored on the second disk. Okay, if first disk gets failed, we have a second disk. There is a redundancy of data, duplication of data, or multiple copies of data is available. It is a fault tolerant, it is a reliable, and it requires a more space. So that is the concept of RAD 1. RAD 1 is known as a mirroring, where we have a same data on the disk 2. So in that we have two disks. Okay, in that we have two disks and the same data of the disk 1 is available on the disk 2. So that is a RAD 1. Advantages: it is easy to implement, easy to understand. Okay, duplicate copy is available. If single disk fail, we have a second disk. What is the disadvantages? Redundancy of data. Okay, the same data is written multiple times. Now RAD level 2. RAD level 2 is known as bit level stripping. Okay, already we know the stripping. Stripping is nothing but we are storing the data on the different disks. In RAD 2 we have minimum 4 disks and your data is divided into the bit level. Bit level चा अर्थ कळतो का? Bit म्हणजे single bit 0 1. Okay, if your data is there, so it is divided into a bit and bits are stored into the two disks. Okay, data storage च्या दोन डिस्क आहेत. ओके, त्यामध्ये bit 1, bit 2, bit 3, bit 4. bit 1 हा डिस्क 1 मध्ये जाईल आणि bit 2 हा डिस्क 2 मध्ये जाईल. ओके, असा तुमचा डेटा काय होईल? स्ट्रिप होईल बिट लेवलला, ब्लॉक लेवलला नाही. इथं डेटा तुमचा बिट लेवलला डिवाइड होईल आणि डिस्क 1 मध्ये आणि डिस्क 2 मध्ये अल्टरनेटिव्हली स्टोअर होईल. सो इट हॅज ऑल्सो अनदर टू डिस्क नोन ॲज ECC, एरर कंट्रोल कोड डिस्क म्हणतात त्याला. ह्यामध्ये वी हॅव एरर कोड्स. ओके, बिट लेवल एरर्स are corrected and these errors are stored into the different disks. ओके, त्यामध्ये पण डिस्क 1 च्या ज्या एरर आहेत त्या डिस्क 3 मध्ये असतील आणि डिस्क 2 च्या एरर डिस्क 4 मध्ये असेल. सो एव्हरी डिस्क हॅज इट्स ओन एरर डिस्क. जर इथं दोन मिनिमम बिट लेवल स्ट्रीमिंग मध्ये 2 डिस्क असतात, त्यासाठी आपल्याला अजून 2 डिस्क लागणार एरर हँडलिंगसाठी. सो एक्स्ट्रा डिस्क आर रिक्वायर्ड bit level stripping. Okay, so there is no redundancy of data but data is stripped and it is easy to find out the error. Okay, so using the Hamming code, this bit level stripping RAD 2 level is in the work. Okay, so it will give appropriate error. Okay, quite difficult to understand but it is a error handling. The data is secure and error free in the RAD 2. Now it is a RAD 3. In RAD 3, it is a byte level stripping. Now your data is divided into the byte. 1 byte means 8 bit and that single byte is stored into the 3 disks. In the RAD 3 there are 3 data disks. So byte 1 is stored into disk 1, byte 2 stored into disk 2, byte 3 stored into the डिस्क 3. म्हणजे तुमचा डेटा बाईट मध्ये डिवाइड होईल आणि बाईट मध्ये डिवाइड झाल्यानंतर आपल्याकडे किती डिस्क आहेत तर रॅड लेवल 3 मध्ये 3 डिस्क असतात डेटा स्टोअर करण्यासाठी. डिस्क 1 मध्ये बाईट 1, डिस्क 2 मध्ये बाईट 2, डिस्क 3 मध्ये बाईट 3. ओके, तर तुम्हाला असा डेटा तुमचा स्टोअर होईल. इट इज अ स्ट्रिपिंग, बाईट लेवल स्ट्रिपिंग. अँड वी हॅव एक्स्ट्रा डिस्क विच इज नोन ॲज अ पॅरिटी डिस्क. ओके, पॅरिटी चेकिंग होतं इथं. एरर चेकिंगमध्ये बाईटमध्ये त्या बाईटला इवन किंवा ऑड पॅरिटी आहे तो आपल्याला चेक करता येतो. अँड इट हॅज अ पॅरिटी डिस्क टू फाइंड आउट द एरर. सो इट हॅज अ एक्स्ट्रा पॅरिटी डिस्क. ओके, इथं इंडिव्हिज्युअल बाईट लेवलला इंडिव्हिज्युअल डिस्क नाही. आपण रॅड 2 मध्ये कसं बघितलेलं, प्रत्येक डिस्कला एरर डिस्क होती. सो इट इज अ सिंगल डिस्क फॉर द पॅरिटी. सो पॅरिटी फॉर ब्लॉक नंबर 1 ची पॅरिटी P1, ब्लॉक नंबर 2 ची पॅरिटी P2, ब्लॉक नंबर 3 ची पॅरिटी P3. ओके, 4 ची इथे येईल P4. ओके, द डिस्क टाइप रॅड लेवल 3 वर्स. In the RAD level tree generally uses the 3 disks. It has a byte level stripping, so it is an advantage of stripping. So there is no redundancy of the data. So data is stripped into the 3 disks. If single disk get fail, so it is damage only 1/3 of your data. So remaining 2 disks are available, and it has a error checking concept of parity. Now it is a RAD level 4. It is a stripping, but is a block level stripping. Now your data is divided into the block, and blocks are stored in RAD level 3. Also we have 3 data disks, and data is divided into block. Blocks are the काय, block is container of bytes. ह्याच्यामध्ये number of bytes असतील, and byte is container of bit. ओके, तर इथं तुमचा डेटा ब्लॉकमध्ये डिवाइड झाला आहे, आणि तो ब्लॉक कसा होईल, ABC. म्हणजे तुमचा जर ब्लॉक डेटा जर आय म्हणजे किती ब्लॉक झाले, टोटल 9 ब्लॉक आहेत, तर पहिला ब्लॉक डिस्क 1 ला जाईल, दुसरा डिस्क 2 ला, तिसरा डिस्क 3 ला, आणि एव्हरी ब्लॉक हॅज इट्स अ पॅरिटी फॉर एरर चेकिंग. ओके, सो इट हॅज अ block level parity, and it has a separate disk. Okay, so it is a 3 disks and extra parity disk. Stripping is used. It is a very good technique to avoid the redundant data. So it is a only single parity disk is used, so it is a economically low price is required. Okay, so because a byte level stripping requires more space, bit level stripping required more space, block level stripping required minimum space. 5. RAD level 5. RAD level 5 has minimum 3 disks, and it is a data disk. It is not having the separate parity disk, and your parity are distributed in the available disk. So there is no need of extra disk, and parity is distributed into that. So disk, in this it is a block level stripping. So block level stripping is there. So blocks are stripped into the different disks. Okay, and their parity is also having on the different disk. आता ह्याच्यामध्ये फक्त एक महत्त्वाचं आहे, इट इज अ गुड परफॉर्मन्स. देर इज नो एनी रिडंडन्सी, गुड रिडंडन्सी अवॉइडन्स टेक्निक आहे. ह्याच्यामध्ये एक की पॉईंट आहे, ब्लॉक 0 ब्लॉक ए हा जर डिस्क 1 मध्ये असेल तर त्याची पॅरिटी ही दुसऱ्या कुठल्याही ब्लॉकमध्ये असते, त्याच ब्लॉकमध्ये सेव्ह होत नाही. ओके, सो दॅट्स वाय इट इज व्हेरी इम्पॉर्टंट. ब्लॉक बी जर डिस्क 2 मध्ये असेल तर त्याची पॅरिटी जी आहे ती आता डिस्क 2 मध्येच आहे. बघा, P2 डिस्क 2 मध्ये आहे. ओके, सो हे काय होतं, डिस्ट्रीब्युटेड केलेले आहे, म्हणजे तुम्ही प्रिडिक्ट करू शकत नाही की तुमची पॅरिटी कुठल्या डिस्कमध्ये असेल. काय होतं, तुमची पॅरिटी कुठल्या डिस्कमध्ये आहे हे कळत नाही. पॅरिटी हेही डिस्ट्रीब्यूट केलेली असते. सो इट इज अ व्हेरी गुड टेक्निक वेअर देअर इज नो एनी एक्स्ट्रा डिस्क इज रिक्वायर्ड फॉर द parity control. Last, RAD level 6. RAD level 6 has 4 data disks. It has a double parity block for every individual distributed block. Okay, it is a double parity block, okay, for individual disk. Okay, so this increases a fault tolerance. Each disk has a 2 parity blocks which store the different disks according to द ब्लॉक स्ट्रिप्ड इनटू द डिस्क. ओके, सिंपल मिनिंग आहे, तुम्हाला कळेल. इथं ब्लॉक लेवल स्ट्रिपिंग आहे, म्हणजे तुमचा डेटा हा ब्लॉकमध्ये डिवाइड केला जातो आणि डिफरंट डिस्कमध्ये आहे. इथं सेपरेट पॅरिटी नाही आणि 2 डिस्ट्रीब्युटेड पॅरिटी आहेत. डिस्ट्रीब्युटेड पॅरिटी किती आहेत बघा, सिंगल डिस्ट्रीब्युटेड पॅरिटी मगाशी होती, इथं 2 डिस्ट्रीब्युटेड पॅरिटी आहेत. आता 2 डिस्ट्रीब्युटेड पॅरिटी म्हणजे काय बघा, एकाच डिस्कमध्ये 2 पॅरिटीचे ब्लॉक येऊ शकतात. ओके, गेल्या वेळी आपण पॅरिटी ज्यावेळी बघितली तर प्रत्येक ह्याच्यामध्ये एकच पॅरिटीचा ब्लॉक आहे. ओके, इथं रॅड लेवल 6 मध्ये आपल्याला डिस्ट्रीब्युटेड पॅरिटी 2 डिस्ट्रीब्युटेड पॅरिटी पर डिस्क असतात. ओके, it is quite easy to teach but not easy to understand in the first glance. So in your syllabus it is only introductory part. So how it is created, what is the technology behind that, so that is does not bother about that. So go into the references, find out what is a RAD, okay, and what is the use of RAD technique. Go to the RAD level 0 to RAD level 6, find out its advantages and disadvantages, and diagrams are very important. Okay, so RAD level 0 stripping, it is a block level stripping. RAD level 1 mirroring, the duplication of data. RAD level 2 minimum 2 disks, and it has a 2 error checking disks, so that is a bit level stripping with ECC. RAD level 3 byte level stripping with dedicated parity disk. Okay, ह्या खालच्या वाक्यावरूनच तुम्हाला कळायला पाहिजे. देन रॅड लेवल 4 इट हॅज अ ब्लॉक स्ट्रिपिंग विथ डेडिकेटेड पॅरिटी डिस्क. रॅड लेवल 5 ब्लॉक स्ट्रिपिंग विथ डिस्ट्रीब्युटेड पॅरिटी. इथे एक्स्ट्रा पॅरिटीची डिस्क नाही, तुमची पॅरिटी आहे ती त्याच डिस्कमध्ये डिस्ट्रीब्युटेड आहे, कुठेही असू शकते. रॅड लेवल 6 ब्लॉक लेवल स्ट्रिपिंग विथ 2 डिस्ट्रीब्युटेड पॅरिटीज. ओके, एका डिस्कमध्ये 2 डिस्ट्रीब्युटेड पॅरिटीज असतील. सो दीज आर द RAD level. Common advantages of RAD: efficiency, reliability, high speed, okay, fault tolerant, they are the same. Only important is that stripping is used bit level, byte level and block level stripping. Okay, if there is a separate disk for the parity or error checking, or the parity is available within the disk. So these are the very important points. Okay, so up till now we have seen the different parts of operating system. In this 6.3, basically there are 3 questions. What is a directory and what are the different level of directory, single level, 2 level and 3 directory structure. So that question is definitely asked. Then what is meant by RAD, and explain any levels of RAD. One single level gives you 2 marks. So generally it can ask 2 levels, 0, 1, 2, or it may ask any level of RAD. So when you are describing the RAD, a diagram is essential. Diagram gives you 2 marks and your explanation. Okay, so that is important. So in this way we have completed unit number 6. In next video lecture we are going to discuss a practical. Okay, up till now we have cleared the 5 practicals. Now it is time to have a practical in next video lecture. Still then, stay at home, stay safe, stay healthy, happy learning.